Welcome back, Ian Gilmore again, and today I'm going to demo another tool of mine, a track tool I wrote for the production of Cars 2 game. As you can imagine, for a racing game, our designers had to design a lot of track, and it takes a lot of iteration to get it just right. Most of the designers weren't my experts, and so they were assembling tracks out of pre-built pieces that didn't allow them as much flexibility as they wanted. Overall, it was a pretty tedious workflow, and so I was tasked to fix it. My goals were pretty simple. Simplify the initial track creation, make it easy to modify the track without rebuilding anything, and finally reduce overall iteration time. Here is what I ended up with. With this tool, you draw a curve, attach the nodes to specify track width and bank, and voila, instant track. After creation, you can modify the curve, add new nodes, change some track properties, click Update and see your changes. You can add walls, snap the terrain to the track, and trim intersecting sections of track.
For Infinity 3, the engine team changed the way that navigation was handled for the Toy Box, which is an open world in Disney Infinity that users can populate from a library of almost 1,500 toys. There was trains of all types, buildings and parts of buildings, vehicles, blocks of all shapes and sizes, all used to create an infinite variety of worlds. These engine changes meant that we had to rebuild the nav meshes for the entire library. Instead of having artists do it all by hand, I was tasked to make a tool that would auto-generate the nav meshes, and this is the result. The Auto Nav Mesh tool. It looks pretty simple, but under the hood it's doing quite a lot. First, the original mesh is duplicated, simplified, and then broken up into ground and wall and floor pieces. Then the pieces are named, grouped, and tagged based on toy data stored in a Luma file. The changes are saved, files exported, and the whole operation logged. The tool can also be run in batch mode, where it is run on every toy in a specified folder. The result is what would have taken weeks of work by hand was completed in a couple days. And in the end, it took longer to test and verify the new nav meshes in the game than it did to create them. I did a lot of tools like this. Whenever there was a time-consuming or repetitive task that could be automated, it was my job to automate it. And with Disney Infinity and the Toy Box and a library of 1,500 toys, there are plenty of repetitive and time-consuming tasks to automate. Early on at my time in Disney, we were having a big problem with artists checking in content that would break the build. Each time that took a programmer like an hour to load the game and debug, find the content that was crashing, and then let the artist know. And it was happening on a regular basis and was becoming a big problem. At first, artists were given a printed checklist of all the things they needed to check before submitting any content, which could take like 10 minutes if they did everything on the list. And you can imagine how many artists followed the checklist. About zero. And bad content continued to break the build. So I created the report card to automate the pre-export tests and catch all the bad content before it even exported, and I'll show you how it works. We'll start with the test picker. This is like a menu at a restaurant listing all the available tests grouped by discipline. You check all the tests you want, set any parameters, and then click Run. And voila, you get a report card for your scene. For each test, you get an error message, a button to select the content that failed. Some tests have automated fixes, and you can just hit the Fix It button to fix the error. And a help button that opened a Confluence page for the test that had an explanation of the test and the error state and how to fix it. Once the error was fixed, you hit Run Last and make sure it was fixed. Each test is an instance of a test class, and that contains all the testing functions itself. The report card tool was just a framework that handles the running and the reporting of all those tests. So it ended up being pretty easy for a programmer or an artist with any programming skill to add their own test. They can just duplicate the test code template, fill in some details, and add a test function, and never have to mess with the code of the report card at all. Once you picked your tests, you can save a test config or import existing test settings. Once you've created a test config, it can be run with a simple line of code. So we were able to create configs for different types of content, like a character test, an animation test, toy box object test, etc. I made an export test config that ran all of the tests for build-breaking content and triggered it as part of the export process. If a test failed, the export stopped and a report card window popped up to show the artist what had gone wrong. But if it succeeded, then it was just silent and they weren't bothered by it at all. So with that, artists didn't even have to think about the checklist at all. It just ran quietly in the background. And that solved our build-breaking content issue.